Well, once again, writing slope-intercept form is going to be what? Okay. Again, that should be very familiar to you. Okay. And then you substitute values in for your x, y, and m to solve for which variable? B. Okay. And then you can rewrite in the slope-intercept form, but you plug in the value of b, so you get your new number for slope, your new number for b to get your equation. Okay. Are there questions on the problem for that? Okay, what about for perpendicular lines? So if lines are perpendicular, what again is the relationship between their slopes? Okay, so it's the negative reciprocal of the slope of the original line. So then once again you do the same steps. You write your equation in slope-intercept form, substitute in your values for x and y, the given point, the slope that you just found, which is going to be the negative reciprocal of the original, and solve for b. And then again you rewrite it to get your general equation form. And so if we are looking for this problem, okay, so if you have the equation of this line, you can solve this equation graphically. You don't even need to do any equation part to it, but we'll talk through both ways. So if you want a perpendicular line, that means what is the slope of this given line? Up 1 over 1, or up 3 over 3 gives you a slope of 1. So what does that mean the perpendicular slope is going to be? It's going to be the negative reciprocal, so negative 1. Okay, so if you plot this point, 1, 2, so here's your point, and you want a graph that is perpendicular. So perpendicular means 90 degrees. Okay, what you could do is you could use your slope to find your y-intercept. So from just knowing this, we have y is equal to mx plus b. Once again, we found our slope, so we can substitute in our negative 1 for that. Okay, what we need to do is find our b. So if our slope is either down 1 to the right 1 or up 1 to the left 1, at what point is it going to intersect the y-axis here? 1, 2, what is this point? This is the point 0, 3. So just by counting it, we could actually find our y-intercept with just a counting. Now, if you're going to do this by using the equations, once again, what you will do is you'll start with the form that you just found, replace your m with the negative 1, because that's what we solved for, and then substitute in your x and your y. So our given x and y is this point. We plug in a 2 for y. We plug in a 1 for x, and we solve for b. So to solve that, we're going to add 1 to both sides. That gives us 3 is equal to b. And then we can substitute that back in to our equation, and that's going to give us our overall equation here. So y is equal to negative x plus 3. It confirms what you got with your visual solution. Okay. Questions on that first, and then we'll do this last problem. Any questions on doing that? Okay. All right, so this last linear model, okay, again, what does m represent in a real-world application? Rate of change, the rate that something is changing, and b represents the whatever the initial original amount is. Okay, so if you take this equation given here, you have in your savings account, and you withdraw $8.25 per week from this account. So you have some amount in your account. Okay, so here is the model. Okay, so here's your account, your initial amount, right? And the rate of change. So So if we look to see what values do we have for this, well, you're taking $8.25 out per week. So is that amount going up or going down? Down. So your rate of change, is it going to be positive or negative? Okay, so we can plug in a negative 8.25 for our rate of change. Okay, and what was the original amount? Do you know? No, you don't know this yet. All you know is that after 10 weeks, you have $534. So there is your set of coordinates, your ordered pair, the information that's provided. When x is 10, so when the time is 10 weeks, what's the amount in your account? 534. So you can use this point to help solve for what your original amount is. You don't know the original amount. That's your unknown. So if you plug these in, we take 534, plug it in for our y, plug in 10 for our x, and solve for b. We'll be able to find our original amount. Once we find the original amount, we can plug that into our equation, which we know is y equals negative 8.25x plus whatever our original amount is that we're going to solve for right here. So if you take 534 and you multiply, negative 8.25 times 10 just means we move the decimal over. Okay, so if you add 82.5 to 534, you get 616.5 as your b value. So here is our equation that models this situation. So the only thing that you need to do now is predict what would the balance be in 20 weeks. So you'll take this equation, plug in your number 20 for which variable? 20 represents the number of weeks, which was right here. So plug that into your x and solve, and that'll give you the amount for that time.